Hello everyone and welcome to today's presentation on vitamin D and coronavirus. So we're gonna go over what is vitamin D and how it is related to coronavirus, as we've seen in the news lately from the pandemic and so on. Okay, so I'm Filippo Ceccagno, I am a registered nutritionist and I'm currently doing a master in genetic and nutrition. So nutrition is my passion and I love eating. Okay, so what is the truth about health and nutrition? So vitamin D, what is vitamin D, guys? What food sources of vitamin D we can find around? What is the role in the body of this vitamin and the recent connection between vitamin D and coronavirus and how it's affecting the infections, okay? So we are going to draw together some conclusion to better understand if actually vitamin D is connected to coronavirus. So what is vitamin D? We got two types of vitamin D, vitamin D2 and vitamin D3. Vitamin D2 is also known as ergocalciferol, and then we got vitamin D3, which is also known as cholecalciferol, okay? So these two vitamins are found in different food. We got vitamin D2, which is found in foods from plants, okay? So in plant food and mainly in mushroom from the synthesis in their body from the exposure to UV light, okay? And then we got vitamin D3 instead is naturally produced in our body by the synthesis of another pre-hormone, 7-dehydrocholesterol, in our skin when we are exposed to sunlight. However, it is not very high, the production of vitamin D in our body, so we really need the exogenous sources of vitamin D. Also, vitamin D3 we can find it in animal products and in supplementation. Both these vitamin D, we can find them in supplementation. So humans do not produce enough vitamin D, and also we just produce the pre-hormone, which is the vitamin D3, okay, cholecalciferol. Most of the one ingested is actually D3, so D2 is quite rare unless you eat a lot of mushroom, and vitamin D3 is actually better raising level of the hormone vitamin D in your blood. So the vitamin D which we ingest, which is vitamin D2 and vitamin D3, is actually not active, so it's inhibited. It needs to go over hydroxylation in the liver and in the kidneys by different enzymes. One of the enzymes is the 1,25 hydroxylase, and the other one is 1-alpha hydroxylase, okay? And then by the hydroxylation, it will then transform to vitamin D or calcitriol, okay? Calcitriol, sorry. So vitamin D in the world, what we know so far. So we estimate that 50% of worldwide people is deficient, and also we know that so far 1 billion people has a level of vitamin D which are low and are not meeting the criteria. And also, as we call it, the vitamin D deficiency is a hypovitaminosis. Okay, so all the vitamin deficiency are hypovitaminosis. So you have an hypovitaminosis, sorry, of vitamin D. So vitamin D levels and health outcomes. So this table is going to help you to understand when you have enough vitamin D in your blood. So it's the serum concentration of vitamin D in your blood. If you got less than 30 nanomole per liter, then this is associated with hypovitaminosis of vitamin D, so with deficiency of vitamin D, and this can lead to rickets, which I don't know if you ever seen, is these poor kids, which unfortunately the mother, for different reason, couldn't get enough vitamin D, and they are born with the bones deformed. Okay, so usually it's in a heart or X. Okay, and also osteomalacia in adults, so osteopenia, osteoporosis, and this kind of thing. Okay. Also, 30 to 50 nanomoles is still considered not enough, and then we go over 50 nanomole per liter, which is the adequate level of vitamin D, which is usually good for bone health and healthy lifestyle, okay? So what are the sources of vitamin D? We just touch on it. Vitamin D is in human is mainly synthesized in the skin, as I said, from the 7-dehydrocholesterol. However, we find it in supplements, in sun, and food from very natural sources. So as you can see here from the image, we got the sunlight, we got the salmon, cod liver, so mainly oily fish in general, caviar, sardines, then we got mushroom, raw milk, and mackerel, and so on. But however, it's estimated that 6 to 47% of vitamin D comes from supplementation worldwide. So in the world, actually, people get most of their vitamin D from supplementation. So how vitamin D synthesis happen in our body? Okay, so we got the pre-hormone of vitamin D, which is vitamin D3 or vitamin D2, and in this case also 7-dehydrocholesterol, which is the one that you find in the skin. Okay, that with the sun, as you can see here, it will then transform to cholecalciferol, which is the vitamin D3. Okay, so we get this vitamin from different sources, as we said, food and supplementation, and these are synthesized mainly in the liver via the enzyme 125 hydroxylase. Okay, they are synthesized in the pre-hormone 25 vitamin D. And is then converted by another enzyme which is found in the kidney, and you can also find it in the blood in some traces, and is 1-alpha hydroxylase, okay, mainly in the nephron of the kidneys. When too much calcitriol, which is the final vitamin D, the active form of vitamin D, is found in the blood, we have actually a negative feedback in place to stop the production of vitamin D by suppressing these enzymes, okay, the enzyme that we just talked about. This happens via reducing the parathyroid hormone, which reduces the calcium and phosphorus reabsorption, which then inhibit the activity of the enzymes. Sorry, guys. So roles of vitamin D. What are the roles of vitamin D in our body? So they facilitate calcium and phosphorus absorption. So it's very important in the intestine to help us to actually absorb properly these two micronutrients. If you think that only 10 to 15% of the calcium and only 60% of the phosphorus is actually absorbed via the intestine when there is not enough vitamin D, that's incredible, guys. So vitamin D enhances their absorption by 30 to 40% for the calcium and 80% for the phosphorus. Okay. So also, why is so important vitamin D? So vitamin D regulates up to 200 genes. That's a lot. Okay. So it means that it switch on and off different genes in our body via the vitamin D receptor. Okay. These genes, they inhibit cellular proliferation, they induce terminal differentiation, inhibit angiogenesis, and stimulating insulin production, which is important for diabetes and other immune response. Okay, so it's important basically against cancer. Okay, so all these pathways, so the cellular proliferation, so cancer, you have the cell that is proliferating madly, so is over proliferating. Okay, so these genes actually when they're switched on or off, depending on which gene, they can actually inhibit these processes. Okay, so other function also are hormonal regulation, as we said, like insulin production and so on, protein mineral absorption, promoting mineral absorption, as we said before, with the phosphorus and calcium, and then also promoting skeletal health. This is really important because it works synergetically with calcium. Okay, so by working together, it helps stimulate the osteoclast differentiation, which are the cell of the bones, and calcium reabsorption in the bones, promoting mineralization of the bone matrix. So vitamin D and immune system. So what we know so far about vitamin D and the immune system? Vitamin D enzymes and vitamin D are actually found in many immune cells, okay? In antigen presenting cells, T cell, B cell, and monocyte. These are our soldiers, guys. They fight against the different threats and pathogens, okay? So metabolite calcitriol, the calcitriol, which is the active form of vitamin D, is actually synthesized in immune cells and has immunomodulatory properties, and it actually activates different cytokines locally. So these cytokines, again, they fight against different threats. So usually cytokines are referred to as an inflammatory response of our body. So calcitriol actually enhances the antimicrobial effects of macrophages and monocytes. These are important again because these are the soldiers that they fight against the pathogens. So they fight against the pathogen. For example, back in the days, cod liver, which is really high in vitamin D, was used actually to treat tuberculosis. So I don't know if you knew that, but it was used for curing tuberculosis, which is a very nasty pathogens that affect the upper respiratory tract. Then we got the complex VDR, which is the vitamin D receptors, as we said before, the calcitriol and the retinoid X receptors, which activates antimicrobial peptides. These are important because they signal to the different cells, so T cell, B cell, which pathogens are entering our body and they need to be fought. So again, going over the immune system function of vitamin D, calcitriol increase the gene expression of cathelicidin, sorry, I can't say, gene, and is promoting the translation into antimicrobial peptides, which are also called CAMP, and again, these are signaling which pathogens are entering our body. Then we got levels of calcitriol, which affects function and morphology of the dendritic cell. These are really important because, again, these are a messenger from the cell to the T cell and B cell of what infection is going on in our body and what they need to fight. So it's a really specific messenger. And these, what happens when calcitriol is not in high level. These dendritic cells are immature and they're not able to transmit the proper message to actually our fight soldiers. Okay, so calcitriol upregulated, as I said before, VDR, which is the vitamin D receptor, which promote the proliferation and differentiation of B cell and T cell. So not only it can fight against the cancer, but also is really important for the B cell and T cell because it helps with the proliferation of them. If you have enough B cell and T cell, you are able to fight the pathogens and the various threats that are entering your body. So low calcitriol is actually linked to elevated mortality by infection and renal disease. Did you know that? And also is actually linked to upper respiratory tract infection, so influenza, chronic obstructive pulmonary disease, pneumonia, asthma, and so on. So only 4,000 units a day of vitamin D has been found to reduce significantly infectious symptoms, nasal fluids, and the use of antibiotics in immunodeficient patients. These patients, they are affected by immunodeficiency, which means that when they encounter influenza or so on, they have really bad symptoms and they're more likely to get infected. So vitamin D actually has been shown in different studies to help with immunodeficient patient against different pathogens. So let's go through what we are really interested today. So vitamin D and COVID-19. So what happened during the pandemics and what are the role of vitamin D against these pathogens? So highlight 3 different studies here today. Okay, so we're gonna go over each one of them and we try to understand better what are the association between vitamin D and coronavirus. So this study was published in 2020, was done in France, in Ronde, and was a quasi-experimental study in a middle-sized nursing home. So it wasn't a really big nursing home. They took 96 participants, 66 of them were affected by COVID-19, and the mean age was 87.7. So they were old people. Okay, so basically the people that is more likely to have severe symptoms of this disease. All patients actually receive vitamin D supplementation, 80,000 units every 2 to 3 months. So, which is worked out by around 880 units per day. In this nursing home, hypovitaminosis is almost 90 to 100% of the population. So they are really high risk of deficient of different vitamins and especially vitamin D because they don't go out and also usually when you get older you eat less and the quality of the food also in nursing home is not the best. Okay, so some COVID-19 received 80,000 units every 2 to 3 months compared to group of COVID-19 patients which actually didn't receive any vitamin D. So what were the outcome of this study? So 51 people actually survived and 15 died, which these results shows that vitamin D participant had 92.2% probability of surviving the virus compared to 66.7% of the people that wasn't supplemented, which is huge, guys. That means that it's almost 30% more survivability compared to the non-supplemented. So the conclusion is that vitamin D-free supplementation during and before COVID-19 is associated with less severe symptoms and higher survival rate in elderly. Okay, this is only an association. Okay, so we can't be sure that it's actually because of vitamin D, but there are good hypotheses. Now, the second study that we are going to look at again on coronavirus was actually carried out by Meltzer and others in 2020 and was looking at vitamin D levels and its association with coronavirus. It was a retrospective cohort study of 489 participants. The participants had their vitamin D level tested 1 year before the pandemic, okay? So they actually knew which group of people was having likely, because they didn't test for vitamin D at present, but 1 year before, they knew which one was likely to be deficient and which one was likely to have sufficient levels. Indeed, they divide the population in two groups. We had 124 in likely deficient individuals and 287 in sufficient levels of vitamin D participants. So the conclusion of this study was that 71 participants in this study tested positive for COVID-19. And the multivariate analysis, which is a statistical test, actually shows that increased age, likely deficient individuals were actually associated with COVID-19 infection, more COVID-19 infection compared to the group with sufficient vitamin D levels, okay? So again, here, there are all the variables, okay? So they might be deficient in other micronutrients. However, this one was focused on vitamin D levels, and they found an association, okay? So this is not conclusive, again, it's an association. This is maybe vitamin D levels was actually one of the causes, okay? And then the last study, which is was one of the most interesting one in my opinion. Okay, it was carried out in 2020. It was again investigating the possible association between low mean levels of vitamin D in different countries and the virus infection and the mortality rate. Okay, so the study focused mainly in European countries, and they look only at the mean vitamin D level of each nation. So they check at the mean level of each nation. For example, as you can see here, 26 nanomole in Spain was the mean level of the population of vitamin D, 28 nanomole per liter in Italy, 45 nanomole per liter in the Nordic countries, so like Norway and Sweden and so on, okay? So they run a Pearson correlation coefficient test, which is another statistical test, which is trying to look at an association between the mean level and the mortality cases per million people and the cases per million people. And as you can see here in the two graphs, when the mean level of vitamin D were rising, so they were high, like 80, 90, and so on, the mortality rate in this population was really low. Whether instead in the nation, which they had a really low vitamin D level, okay, so 40, 50, and so on, the mortality rate was increasing dramatically, okay? So as you can see, there is a linear correlation between the two variables. Same in the cases per million people. Again, there is my face here, but it is going down again as the mean level of vitamin D increased, okay? So there are these countries, which I just highlighted and I told you, like Spain, Italy, and Nordic countries, at the moment of the studies, at the time of the study, they were the countries with the highest number of COVID-19 cases, and the aging people group in this population were a higher risk of morbidity and mortality by COVID-19, okay? So this is very suggestive. It's looking at different countries, so it's quite big, okay? However, they didn't test the people for vitamin D. However, they looked at the database and they checked what was the mean level on the different questionnaire, food frequency questionnaire, and so on. So what are the conclusions of today and of this presentation and what we saw so far, okay? So early papers actually suggest that vitamin D might be linked to COVID-19 and might be the central biological determinant of the current COVID-19 outcomes in terms of mortality cases and severity of symptoms. However, I'm not really agreeing with this affirmation. I don't believe that only vitamin D is the central biological determinant. There are other different factors like obesity, overweight, diabetes, underlying condition, and so on, and also genetic predisposition. So vitamin D, calcitriol, has an important role in the immune system, as we've seen, proliferation of B cell, T cell, macrophages, monocytes, bring the messages of the current threat in the body to our soldier, and so on. And the response that actually the outcome of our body and the response to this virus and different other viruses, especially upper respiratory tract viruses. Vitamin D also reduces inflammation, and this is really important, especially because I don't know if you noticed, but most of the people that died from COVID-19, at least in the early stages, was because there was an acute reaction, inflammatory reaction to the virus, and vitamin D can help to lower the inflammation in the body and these reactions, so less severe symptoms. And there is a possible correlation between low mean levels of vitamin D, as we said before, which is less than 15 nanomole per liter or 20 nanogram per milliliter in the blood, and COVID-19 and severe symptoms, mortality in older adults. So it's really important that you have enough level of calcitriol in your blood. So the serum level concentration should be quite high. Okay, so eat more food containing vitamin D and get some sunlight. Okay, so here also I highlighted a link, which is the Sachin report on vitamin D and health. It's 365 pages, I think, or maybe more, on just vitamin D and the different role of vitamin D in the body, the population, the deficiency, the toxicity of the vitamin D, and so on. Okay, so it's really important and it's really suggestive. So if you want to go and read more, you can go at this link over here and look at the report. Anyway, what are the takeaway of today? So vitamin D and coronavirus, they might be linked together. So try to go and have more vitamin D. Okay, so also it's really important for our hormone, endocrine system, insulin levels. So, and we really, as a population in general, we don't get enough vitamin D, most of us. So don't be scared to get a too high toxic level of vitamin D. Obviously, if you take supplementation of vitamin D, don't eat liver all day or so on, which are containing really high level of vitamin D, because it might give you adverse effect. But if you want me to go over the toxicity of vitamin D, I can do that. Just pop me a comment on the video down below. Please remember to subscribe, click the like button, and just let me know what other micronutrients are interested on, if you have any question, and I will be happy to respond to any of your questions, guys. Here, I'm going to show you just after this slide, there are the references, and then I will go off, okay? Filippo Ceccagno, see you later.